Hello, Algebra 2 honors. Today we are going to cover the last section of chapter 13, which is on statistics. So going to our first example here, I have a data set of 12 values, and typically when you are working with data like this, you always want to arrange the numbers from smallest to largest because it's going to make things a lot easier when you're calculating things like median or range or quartiles, which we'll talk about later. The first thing we'll talk about is the mean. The mean is another word for average. The symbol we use for mean is x bar, which is x with a bar on top. And to find the mean, we just take the sum of all the numbers and divide by how many numbers there are. If you work this out carefully, you should get 60 over 12, which is just 5. Next up is the median, which is the middle value. Now, in this example here, we don't have a middle value because we have an even number of numbers, right? We have 12 numbers. So what you want to do to calculate the median is you look at the two middle numbers, which in this case would be 5 and 6, and you're going to simply find the average of the two middle numbers. In this case, the average would just be 5.5. For the mode, that's the number that appears the most. In this case, it's just 1 because it appears 3 times. Keep in mind for any given data set, you can also have no mode, and you can also have more than one mode. Lastly, we have the range, which is just the largest number minus the smallest number, which in this case is 11 minus 1, and we get the range to be 10. We're going to continue with the exact same example, but now we're going to look at something called deviation. Now, deviation is just the difference between a value and the mean of that set. So a lot of times when I'm calculating deviation, what I like to do is make this kind of chart. And all I did was in the very first column, I listed out the 12 numbers in my data set. My second column is where I calculated my deviations. So if you look at the second column here, I have x minus x bar, right? X is just a number in my data set, and x bar would be the mean, which we found in earlier, which was just 5. And so the second column here, I took each data value and I subtracted it by the mean. And so here you get these 12 numbers. Because once you find the deviations, you're going to use that to eventually calculate what we call the variance. Now, variance, the symbol that we use for that is sigma squared. And so to calculate the variance, what you're going to do is you're going to take the sum of the squares of the deviation. So in column 2, this was all the deviations, right, that we calculated. What I do next is I square all these values. And that's what the third column is right here. I just squared all the values in my second column. Once you find the squares of the deviation, you're going to pretty much add them all up, which in this case, if you add them up, you should get 108. And then you're going to divide it by the number of values. When you work that out carefully, you should get 108 over 12, which is just 9. Once you find the variance, you could use that to find what we call the standard deviation. Now, standard deviation, the symbol that we use for that is just sigma, which should give you an idea of how you're going to find standard deviation, right? Because if variance is sigma squared, sigma would just be the square root of the variance, right? And that gives me the square root of 9, which is 3. So standard deviation, what it does is it gives you an idea of how spread out the data is. And so, in other words, when you have a data set with a super high standard deviation, or just a high standard deviation in general, the values are going to be more spread out, right? When the standard deviation is small, the values tend to be more closer together, right? There's less spread, in other words, okay? Same example, right? We're going to look at something called quartiles. When you hear the word quartiles, you might think of words like quarters or quadrants, or even quarts and gallons, right? Things like that. And so when we talk about quartiles, those are just going to be values that divide a list of numbers into quarters. And so we have 3 quartiles, right? The first quartile, which we also call the lower quartile, and the symbol that we use for that is called Q1. That's going to be the median of the bottom half of the data. So in this particular example, we have 12 numbers in the data set. And again, it's very important that we order them from least to greatest. When you cut this list in half, right, imagine just a line cut right here in the middle between 5 and 6. So what we have is this bottom half, right, which goes from 1 through 5. And then you have the top half, which goes from 6 to 11. So to find the lower quartile, what you're going to do is you're going to focus on the bottom 6 numbers, and you're going to find the median of that data set. And so if you do that, the two middle numbers here would just be 1 and 3. Take the average of 1 and 3 and you get 2. To find the second quartile, well, we were actually found that, thankfully, and that was just the median. Q2 in this case would just be 5.5. The upper quartile, or the third quartile, is going to be found very similarly to the lower quartile. What you're going to do is you're going to look at the top half of the data set, which is from 6 to 11, and you're going to find the median of the top half of the data. So in this case, the two middle numbers would be 7 and 7. And so when you find the average of those two, you get 7. And that's going to be Q3, your upper quartile. And so what these quartiles do is they divide the data set into quarters. So this is a box and whisker plot, which we're going to make in a little bit. Here is my first quartile, right? Here is my second quartile, and here's my third quartile. And the idea is that these three quartile values, they break up the data set into quarters, right? 25% of the data lies between the minimum and the first quartile. 25% of the data lies between quartile 1 and quartile 2. 25% of the data lies between quartile 2 and quartile 3. And 25% of the data lies between quartile 3 and the maximum. And so that's why they're called quartiles, because they divide the data set into quarters, okay? Lastly is the interquartile range, and that's just going to be the upper quartile minus the lower quartile, which becomes 7 minus 2, which is just 5. So what we're going to do next is we're going to actually create this box and whisker plot. And their name for that is called the box plot. And so when you're creating the box and whisker plot, there's always 5 values that you need to figure out. So the first one is the minimum value, which in this case is just 1. Then you want to find the first quartile, which we found earlier, which is 2. We found the second quartile, which again is the median, which is 5.5. We found the third quartile, which is 7. And then you also want to find the maximum value, which in this case is just 11. So once you find these 5 values, what you're going to do next is you're going to make a number line. And if you notice in this number line, there's 5 points, right? And those 5 points correspond to those 5 values on the left. So I have the minimum value. I have the first quartile, which is Q1. I have the median, which is the second quartile. I have the third quartile, which is Q3. And then I have the maximum value. After you draw those 5 points, if you notice, I connect the middle 3 points with like a box, right? And I have straight lines at the ends. And so this is how you're going to make a box and whisker plot. Guys, at this time, it's your turn to try a problem. I would get a calculator out. I would pause the video and I would work this out. And when you think you're done, I would press play to check your answers. So feel free to pause the video now. Here are the solutions. Check your work. See if you got them right. If you made any mistakes, try to figure out where you might have gone wrong. In particular, the variance and the standard deviation are the two that probably will cause the most problems just because there's so many steps involved. But hopefully you did a good job on this example. The last concept we're going to be talking about today is something called the normal distribution. It's going to describe how the values of a variable are distributed. So on the left is actually the graph of a normal distribution. And one of the things you'll notice is that the mean is the value that's right in the middle, right? X bar is my mean. And the standard deviation is used to label these intervals, right? To mark these intervals. And so with a normal distribution, what you're going to notice is that a majority of the data will lie close to the mean, right? So 68% of the data we say would lie within 1 standard deviation of the mean. And then 95% of the data would lie within 2 standard deviations of the mean, which means if I start at the mean here, if I go within 2 standard deviations above it or within 2 standard deviations below it, right? If I'm looking at this interval right here, that would represent 95% of all the data. And so again, as you get closer to the mean, more and more data will be around the mean. And the further you get away from the mean, you have less and less data there. A couple things to also note is that this graph looks like, it's called a bell curve because it looks like a bell, right? And so it has that type of symmetry that's very useful when we're trying to calculate probabilities, right? Because if you notice 50% lie on the right half and 50% lie on the left half, and again, all the values are the same, right? The percentages are the same. So there is that symmetry that's going to be very useful when we're calculating the probability for these various problems, which we're going to be looking at real soon. So let's look at this first example, right? The weight of a group of babies is normally distributed with a mean weight of 7 pounds and a standard deviation of 1.5 pounds. The first thing we want to do is we're going to sketch and label a graph of the distribution. All I did here was I just took the graph from the previous slide, but if you notice, I did label my mean and my standard deviations, right? How many standard deviations I'm away. So my mean is 7, and if you notice, I just added 1.5 because I'm going 1 standard deviation above it and then eventually 2 standard deviations. I subtracted 1.5 as well because I'm going x bar minus sigma and x bar minus 2 sigma. And so this is what your graph is going to look like. And now once you have this graph, what we can do next is we can actually answer some probability questions. So for example, what is the probability that a randomly selected baby weighs between 4 and 7 pounds? Looking at our graph, I see 4 pounds and 7 pounds. To find the probability, all you're going to do is you're going to add up the percentages that lie within the interval from 4 to 7. So here I'm going to take 13.5%, add it to 34%, and when you do, you should end up with 47.5%. So in other words, there's a 47.5% chance that the baby will weigh between 4 and 7 pounds. What is the probability that a randomly selected baby weighs at least 8.5 pounds? So here we're going to go to 8.5 pounds. And because you weigh at least 8.5 pounds, we're going to look at the values to the right of it, right? And so here we're going to look at these two percentages, 13.5% and 2.5%. And when you add those up, you'll end up with 16%. And that's your answer, right? That's the probability that the baby weighs at least 8.5 pounds. So you're just going to add the appropriate percentages depending on the intervals that you're looking at. For the next question, right, what is the probability that a randomly selected baby weighs at most 10 pounds? So at most 10 pounds just means you weigh less than or equal to 10 pounds, right? So here we look at 10 pounds, and we're going to look at so we want to add up all the percentages that are below that, right? Now, the thing is, I know for a fact that this all adds up to 100%, right? And so really, when I'm trying to find all the percentages on the left side, I'm really just excluding the 2.5%. So the quick way to do this would be just do 100% minus 2.5%, and you'd end up with 97.5%. Lastly, what is the probability that a randomly selected baby weighs between 5.5 and 8.5 pounds? So looking at this graph, I see 5.5 and 8.5 pounds. The probability that my baby lies between these two weights would be the sum of 34% and 34%, which we said earlier, 68% lie within one standard deviation away from the mean. So using our normal distribution graph, we can answer a bunch of different probability questions, and that's how that works. Your turn. At this point, same thing like we did before, I would recommend you pause the video, work at these questions, and then when you think you have your answer, press play. So feel free to pause the video now. These are the solutions. Hopefully you're able to create the same graph that I did. Check your work, and once again, make sure you're adding the correct percentages, right? And hopefully you're able to do this correctly. So this is our lesson on statistics. I hope you guys have a wonderful rest of your day.